How can a function remember something after the function that created it is already gone? That's the mystery that we want to solve today. Now I just want you to focus on this function definition. We have a function outer which has a variable secret that holds a value I know JavaScript. This function is returning another function named inner, whose function definition consists of a log statement which tries to print secret. Now on our line 9 we have a constant fn which is storing the output of outer. Now this is interesting. Fn is storing the output of outer. What is the output of outer function? It is this function definition. So Fn literally has the function definition of inner. So if I call Fn now, essentially what I am doing is I am calling inner. Now if I invoke inner, what do you expect? Is secret the variable of function inner? No. Then what is the output that you are expecting at this moment here? Let's just try to run this and see what is the output. Now how does inner know that secret is I know JavaScript? That, my dear friends, is closures for us. So our general mental model with respect to functions is that if we run a function, it will create its own execution context. Its variables will live in their local memory. When the function is gone, its variables will disappear. We are done with the function, correct? But now I want you to think in this way. When a function is created, it also captures its surrounding variables. It stores those variables somewhere hidden, and these variables stay alive as long as the function exists. Now what do you mean by this? Now let's think on this function again. So when I created a function inner, what I am trying to say is, at the time of creation of inner, I am also saving surrounding variables. What is the surrounding variable here? Secret. So that is how inner knows the existence of secret. Now here is an interesting thing that should help you understand this again more. Now when the outer execution context is created, the inner function's execution context will be on top of it. But with respect to scoping, the outer variable's scope is wider than inner variable scope. So inner function's scope is inside the outer variable scope. That is why inner can access secret variable and can know about its existence. So when I return the function inner, my fn which basically is the function definition of inner, was able to print secret. Now this is very powerful. Now let me take another example. Now we are trying to create a counter which basically just is incrementing its count. Okay, so what do you expect on line number 24, 25, 26? What should be the output? Let's run this and let me know in the comments if you guessed it right. 1, 2, 3. Now how did this happen? I'm sure most of you must have guessed something different. See, when we are on line number 22, when we created counter, we returned this function. So counter is closed over variable count. Count gets incremented, it prints count 0 to 1, right? Now next time when I again call counter, I hold the reference of count. Closures, they hold the variable by their reference. I already have the reference of count. Count is 1. Now when I call it again, it increments to 2 and I print 2. When I call it again, now it will be 2 plus 1 and I will get 3. This is. Now you will say, why you created closure for such a simple problem? I could have just written a statement. As an example, you could have just created a variable let count somewhere. You could have written a function increase count, and you would have said whatever is the count's value, just to count plus plus, correct? Let's say my count was initialized to 0 and I did count plus plus. The problem here is someone can come and directly put in a value 999. Now I cannot be guaranteed that the variable count is accessed through only increase, correct? So what this function did, create counter, it gave us data encapsulation. That is why the term closure. It gave us protection to our variable count. It gave us a method through which we can increment the count, and this is the only way with which count can be accessed. Okay. Now this opens us to a lot of possibilities, correct? Let me open this function. See, now this is a very simple function where I am creating a bank account with an initial balance. Now I don't want anyone to increase my bank balance arbitrarily. It should be increased or decreased by only deposit or withdraw, and if I want to know the balance, it should come from a get balance method. So here, by returning this object basically remembers balance. It is closed over variable balance. So when I call create bank account with 1000, what I get is a account object which has methods deposit, withdraw, get balance. Now when I call account.deposit 500, my deposit should increase by 500. As you can see, we got 1500 here. So this is the power of closures. I hope you understand the concept. Now there is one famous interview question. We will try to. I want you to pause the video and guess the output for this function. So many of you might have guessed that I would get 1, 2, 3. Now here comes the mystery. My output is 4, 4, 4. Now why did this happen? And the interviewer will ask you, how will you rectify this? First question is why. So let's get to the why part of it. We have a var I. Here I is a of type var. Var has a function scope or global scope. Now set timeout API, it will be executed in where? It will be executed in your event loop as a macro task. Now by the time your set timeout is executing, each function that is closed over I has reference to the same variable I, because it is holding it by reference. So my I, by the time this set timeout executes, will be 4, because I is less than or equal to 3. I plus plus will get executed, I will be at 4. So every function after 1 millisecond returns 4, 4, 4. This happened because of closure. Now how will you break out of it? Okay, I need something that is block scoped. So what is block scoped? Late is block scoped. So if I change this var to late, now every function that is holding or is closed over I has a different copy of I. That is why when I was 1, this function, there will be a copy of function which is holding I with value 1. When I becomes 2, another function will hold that value. When I becomes 3, there will be a third. So each function we will have, and now you can expect the output to be 1, 2, 3. So the idea here is closures capture variables by reference. Now let's improve upon this. Now let's say I want to create a function factory wherein if I give multiply by any number, I should get those functions. I mean, if I say multiply by 2, then my number should be 5 multiply by 2, 10. If I say multiply by 3, and I pass the number 5, it should give me 5 into 3, 15. Now are we going to write these many functions? I mean, now you are asking me for double, triple. Okay, I wrote two functions, one is giving me double, another one is giving triple. What about someone asks me, give me a quadruple? Am I going to write again? So I don't want to repeat myself again. So this is where the concept of function factory will come in. So I wrote a function multiply by, I will pass it a argument multiplier, I will return a function which is simply number multiply by multiplier. So if I want to have a double of a number, first I will invoke multiply by with 2, so that double will point to this function. Now if I call double with an argument 5, the function that will execute is function with argument 5 multiply by 2, because remember double is closing over the multiplier. What was the multiplier? 2. If I go with triple, same thing will happen. My function triple is closed over 3, its multiplier is 3. Now when I call triple with 5, I will get 5 into 3, 15. So this is the concept of closure. Once you understand closures, you stop writing JavaScript and start engineering with it. Okay, I hope you understood this. Now I want you to exercise this concept with a problem definition. The problem definition is, you have to write a function once that accepts a callback as input and returns a function. When the returned function is called the first time, it should call the callback and return that output. If it is called any additional times, instead of calling the callback again, it will simply return the output value from the first time it was called. So I have a function num, which is basically adding 2 to the given number. What I want is, if I execute this function once, next time onwards it should not execute. It should directly return me the output of the function that was called very first time. So add by 2 once was called this here with 5, it should log 7. But afterwards if I call it again, whatever be the argument, I should always get 7. So effectively this function should execute only once. That is the exercise. Please try it on your own. Let me know in comments if you found the solution, and if you found this insightful, please do like. I post such videos regularly on JavaScript, so stay tuned. Thank you.